In this section, when we're looking at compound interest, we're going to gain a new formula. It's still going to be exponential like the first half of this lecture was, but we're going to have to identify some variables and kind of work through it a little bit. So a couple of things. First of all, this is your compound interest formula here. It will be something that you need to memorize. It won't be anything that's given in notes or on the exams. Make sure you understand it, you know how to work with it, and you have it memorized, such as the quadratic formula that we've been using. Knowing the formula and also knowing how to work with it can both be very beneficial. First of all, P right here is the initial amount. It's known as your principal. It's the amount that you borrow or invest. 1 is given in the equation, plus rate. R is your annual percentage rate. If it's given to you in a in a percentage, you want to make sure you change it to a decimal. N is the number of compounding periods per year, such as if it was annual, it'd just be 1. If it's a biannual or semi-annual, it'd be 2. If it is weekly, we're talking about there's 52 times in a year. If it's daily, we're talking about 365 times in a year. If it's done monthly, there's 12 months in a year. So it just depends on how many times they tell you that this is compounded. So n is how many times per year it's compounded. You see n right here again. Again, this is in the exponent. We're looking at exponential functions. And then t is your time in years. So a couple of key things that students normally miss. First of all, time is in years. If they give it to you in any other unit than years, you need to convert it back. Your rate is always going to be used in a decimal. Let me write that clear. It's always going to be a decimal that you want to use. So if you're using a percent, make sure you move that decimal 2 places to the left and use the decimal value. And then n is your compoundings per year. So let's kind of do some examples and play around with this equation. If you invest $3,000, so remember, P is the amount that you invest or possibly borrow. That's your kind of starting amount. So if you invest $3,000, that's our P, in an investment account paying 3% interest, so that's our R, compound it quarterly, there's one I didn't put up there. Quarterly is 4 times a year. So compound it quarterly, that's your N equal to 4. How much will the account be worth in 10 years? There's your time. So I always like to first write my equation, identify my variables, just like what we did with our quadratic formula. So my principal is 3,000. That's the amount that I'm investing. My rate is 3%. Remember, your percent needs to be written as a decimal, so I'm going to move it 2 places to the left, so it'd be 0.03. It's compounded quarterly, so it means n would be 4. And we want to know how much it is worth in 10 years. And that is in years, so I'm going to use the 10. So now that I have all my variables identified, I'm going to plug them in. So this would be 3,000, 1 plus your rate, 0.03, over n, which is 4, raised to the 4 times 10. Now, when you're working with this, as you saw in the first part of this section, we have to use our calculator through this entire unit. But when you go to your calculator, I just don't want to let go of control and have it doing so much for me that I don't understand where it's getting the numbers. So I want to do as much as I can kind of on my own, putting things together. So first I'm going to go ahead and figure out this 0.03. So 0.03 divided by 4. And so that gives me 1 plus 0.0075. And then 4 times 10 is 40. So I'm going to do as much calculations as I can before I just run to my calculator. It's going to be in your calculator that you have arrows. Now I'm going to go slowly. Remember order of operation. You want to do your exponents first before you multiply. You do not multiply 3,000 by this. You want to raise this to the 40th power. So in my calculator, I'm going to say 1.0075 raised to the 40th power. I'm going to retain that answer in my calculator. Then I'm going to multiply it by 3,000. So I'm going to say times 3,000. So that gives me A equal to, now that I've done all my arithmetic here, now I'm going to round it. So this would be 4045. I'm working with money, so I'm going to go to 2 decimal places. So since the third one is a 5, it'll round this one up, so I get 0.05. And this is money, so my final answer would be $4,045.05. So, key things to remember. Write your formula. Identify your variables. Plug them in. Go slow. I would not dare try to plug all of this in my calculators because you're going to miss a parentheses or something somewhere. Tiny mistake, like maybe leaving off this multiplication sign. And then you've missed the whole problem just because you made a small calculator error. So go slow, show your steps. Also, in showing your steps, I can give you partial credit or help you out with the problem along the way if you miss a little piece here or there. Let's do another one. So it says, a certificate of deposit is a type of savings account offered by banks, typically offering a higher interest rate in return for a fixed length of time you will leave your money invested. If a bank offers a 24-month CD with an annual interest rate of 1.2%, compounded monthly, how much will $1,000 grow over 24 months? So let's kind of put this to use. I'm going to write my formula. A is equal to my principal times 1 plus r over n to the nt. So, okay, I'm trying to figure out how much. So, P, I'm investing $1,000. That's my investment or my principal. R, it's a 1.2%. But again, you want to change that to a decimal. So that's going to be equal to 0.012. Compound it monthly. So that means n is going to be equal to 12. And then time, it's over 24 months. Well, remember, that is in years. So 24 months will be equal to 2 years. If you miss this unit using 24, you're going to get a much bigger answer than you need it. Now I'm going to plug it in. So this gives me 1,000 times 1 plus 0.012 divided by n, which is 12, raised to the 12 times 2. So again, I'm going to do as much arithmetic as I can. So I'm going to go over here to my calculator so you can kind of see what I'm doing. 0.012 divided by 12. So I'm going to say 1 plus 0.001. 12 times 2 is 24. So that would be 1,000, 1.001 to the 24th. Again, I want to raise this exponent first. And so I'm going to say parentheses, 1.001 raised to the 24th. Retain that answer in your calculator, hit times, so it's going to take my answer times this 1,000. So I get A to be 1024.28. This is money, so I want to round to 2 decimal places. Now do not set, some students will set their calculator to round a certain amount of decimal places. Do not do that. It will round the whole way you're doing that. And if you round anywhere along the way, then your answer is going to be very off because it's overly rounded. So you can see here, how much will $1,000 grow over 24 months? It's going to grow about $24.28. But hey, it's $24 you didn't have before. So compounding interest, it's all going to revolve around how many times you're compounding, either quarterly, monthly, semi-annually, annually, etc. But when we continue our conversation, we look at one that's compounding continuously. We're going to use one that looks more like the equations we were doing in the first part of this lecture. So if we're compounding continuously, we get a new formula here. We get A equal to PE to the RT. We've already had a conversation about E. It's not a variable, it is a value, but you'll notice similarities with the other ones. P is still your initial amount or your principal. This is the amount that you are investing or borrowing. T is your time in years. Be careful of that. And R is your annual percentage rate. And again, we want to make sure this is in decimal form, not a percent. So let's work some of these problems. So here's an example. A person invests $1,000 in an account earning a nominal interest rate of 10% per year, compound it continuously. That's your key word to know that you need to use this difference of equation. Then it says how much was the account at the end of 1 year. So a person invested 1,000. So I'm going to say A equals PE to the RT. Sometimes I call that PERT. Where P is my principal, I'm investing 1,000. E is not a variable, it's a value. R is my rate, and it's 10% per year. So 10%, and I'm going to change it to a decimal, move it 2 places to the left, so 0.10. Let's see, earning a nominal interest rate of 10% per year, compounding continuously. That was my keyword to use this equation instead. How much was the account at the end of 1 year? So my time is going to be equal to 1 because it's in years. So I'm just going to plug in everything I know. 1,000 e to the r, which is 0.10, t, which is 1. So I'm going to do as much arithmetic as I can before I run to my calculator. 0.10 times 1 is just 0.10. And again, when you're typing this in, I would not type everything in at once. I would first do your exponent. Now your E button, again, is located underneath this LN, so I do second E. Already opens a parentheses for me, so I'm going to put 0.1 there. So that's this value. Times, I'm going to multiply it by 1,000. So this gives me a value of 1105.17. Again, this is money, so I went around to 2 decimal places. They shouldn't have to tell me that because we know money is already 2 decimal places. So I want to kind of work one of these, and I want to do one that was compounding continuously, so you can kind of see how this follows suits. It's just a little bit different formula. Next thing we're going to work with is just any exponential function and creating equations to go with those exponential functions. So we're going to kind of take a break from the interest perspective. So let's look at this. It says, in 2009, 80 deer were reintroduced into a wildlife refuge area from in which the population had previously been hunted to elimination. By 2015, the population had grown to 180 deer. If this population grows exponentially, find a formula for the function. So we're trying to find some equation. Information that we know is, in the year 2009, we had 80 deer. So talking about our population and our time. And then in 2015, we had a population of 180 deer. Now, we've already said this before in other sections and even earlier in this lesson that we typically never use this 4-digit year. So we're going to let t equals 0 represent the year 2009. And we're going to let, let's see, to get from 9 to 15, it would be plus 6. So we're going to let t equal to 6 represent 2015. So I don't want to use these numbers here. I want to use the years of the difference of them. And then I'm going to use the populations. So what you want to do is you want to first set up kind of an equation here. So I'm going to say f of t is equal to my initial quantity, which was 80. We learned that at the beginning of this section, times some b, my exponential, raised to time. So I'm going to use kind of the first piece of information to figure out my initial quantity. Then I'm going to use the second piece of information to find what base should be on my exponential, or what is my rate of increase here, basically. So this is going to be our f of t value, and there's our t value. So I'm going to say 180 is equal to 80 b raised to the 6th, and then I'm going to solve this. So I'm going to divide both sides by 80. I get b to the 6th equal to, let's see, 180 over 80 is 9 over 4. And then just like getting rid of a squared or a cubed, I'm going to 6th root this thing. So it gives me b equal to. Now to do 6th root on your calculator, I want you to notice here that there's the square root right there, and then the one above it has an x square root. So I'm going to first enter a 6 and then an x square root. So it's putting that 6 right there of parentheses 9 divided by 4. So I'm going to take the 6th root of 9 over 4, hit enter, and that gives me 1.145. So that is my rate that I'm going to be working with. Now I can rewrite the equation. So this gives me f of t equal to 80 times 1.145 to the t. And so I was able to use the initial quantity to find my initial value and the next amount of quantity to find my rate of growth. Again, if you relate this all the way back to those formulas we were doing at the beginning, then this would also be written as 80 of 1 plus 0.145 to the t. We talked about having that b, or the 1 plus r is the same thing, so kind of two different options there. Now I want to go further. This had a real application to it, talking about the deer and the population. Let's go back and let's just look at a graph of an exponential. And I want to work an example like this, and you have one in your homework where it says find a formula for an exponential function passing through the points. Now we're not doing linear function where we could just do slope and y equals mx plus b. We're going to have some steps for this. So make room on your paper. You're going to have to take a little bit more room to write this. So what we're wanting to do is we're wanting you to set up an equation, f of x equal to ab to the x, an exponential equation. So we're going to do some steps. I'll write them as we go. So first thing we want to do is we want to write two equations. So to write two equations, here's my x and here's my y, here's my x and here's my y. So I would say, okay, using the first order pair here, y is equal to your f of x, same letter there. So 6 is equal to a b to the negative 2. And my other equation would be 1 equal to ab to the first. So first thing I'm going to do is I'm going to write my two equations with x and y plugged in here to my exponential. Step 2, we want to solve one equation for one of those missing letters. And we're going to solve the first one for, say, a. Irrelevant whether it's a or b, but just solve for one of them. So I'm going to use this equation here, 6 equal to ab to the negative 2, and I'm going to solve for a. Well, this is being multiplied by b to the negative 2, so I'm going to divide by b to the negative 2. This cancels, and I get a equal to 6 over b to the negative 2. But working with exponents, we saw this at the beginning of the section, we can move this piece up to the top, and that would be 6b squared is equal to a. So now I have it solved for a. Step 3, I want to substitute into the other equation. Because both of these values have to be true. Both of these order pairs have to be true for this exponential. So I'm going to take what I found to be a, and I'm going to plug it in all the way up here for my second equation. So I'm going to say 1 is equal to, instead of a, I'm going to put 6b squared times b to the first. Now I have it in one variable, and I can solve for that variable. So b squared and b to the first, using rules of exponents, give me 6b cubed. Divide both sides by 6. So I get 1/6 equal to b cubed, and then cube root to solve for b, just like we did on the previous one. So you want to go in your calculator. Again, I'll show you this here. So again, we're going to use this button here, this button right here. So I'm going to do the cube root of parentheses 1 divided by 6. This gives me about, excuse me, let me go back. Right here, you didn't catch this. Right here, my x was 2, so this should have been squared. Let me drop down here. This one is squared. So it's a 4th power. It's a 4th power, and we're going to 4th root it. I apologize for that mistake. So when we 4th root, I knew my number wasn't looking right. So when I 4th root it, I'm going to do the 4th root of 1/6. That gives me 0.6389. 0.6389. So I have now solved one of my letters B. Now two more things. Step 4, we're going to plug back into the first equation. Plugging that back into the first equation, notice we already solved it for a here, so now I could just say 6 times 0.6389 squared would be equal to a. I'm just taking this value here, plug it in here for b. Again, go to your calculator, so I could say 6 parentheses. I'm going to go ahead and use my answer. Down here at the bottom where this negative is, it has an ANS button, and that takes my previous answer, and I'm going to square it, and I get my value for a. So I get a to be equal to approximately, again, I'm going to kind of write this to a few decimals, 2.4495 5. And then last, I can write my equation. So this would be f of x is equal to a 2.4495 times b, which was that 0.64, round it, make it smaller for you, and then to the x power. Just be careful of your rounding. Try not to round to the very end, and then just follow the instructions on if they have you rounding to 2, 3, 4 decimals, etc. Let's do one more of those, kind of in a different format. And I'm not going to mark out the steps 1, 2, 3, 4, 5, because notes-wise, you already have that down. So it says, find an equation for the exponential function that's graphed. So the last one said, find a formula passing through the 2 points. Same concept, different wording. So I'm going to first find 2 really good points. I mean really good points, like you want one that's kind of passing through a grid point, where as you can see this one's not passing through a grid. So I'm going to use this point here that's at -1, 1. Then I'm going to use this point here that's at 1, 2. So same process as the previous example. So here's my x and y. So I'm going to start with kind of my template, f of x is equal to ab to the x. And the first thing I'm going to do is I'm going to write 2 equations. So I'm going to fill this in correctly this time. 1 is equal to ab to the -1. And I'm going to plug these in and get my second equation and say, okay, 2 is equal to ab to the first. Now that I have 2 equations, I'm going to solve one of them for a letter. So in this one, I'm going to solve for a like we did in the last. So I'm going to divide both sides by b to the -1, which gives me, again, negative exponents can be brought up. So it gives me b equal to a. I'm going to use that information into my second one here. So I'll say 2 is equal to, instead of a, I'm going to call it b, b1. Combine that together, and that gives me b squared. So then I just square root both sides, and b is equal to the square root of 2. Once I have that answer there, I'll say, okay, go back to over here. Well, if b is equal to square root of 2, going back to where I made it equal to a, that means a is also equal to the square root of 2. So now I can rewrite it. F of x is equal to the square root of 2 times the square root of 2 to the x. I don't want to put these together and kind of work with my exponents. I just want to kind of leave it separately. And that would be my formula. So I hope this helps to round out the end of this section. If you have any questions, feel free to let me know.